Welcome to episode 21 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so interesting to astronomers. So, I will now run the random number generator.
24, atom bomb.
And the random number generator has completely filled my apartment with smoke. However, I can still read the coordinates, which are 0 hours, 52 minutes, 25.1 seconds for ascension, and plus 56 degrees, 33 minutes, 54 seconds declination. This points to the star-forming region NGC 281 in the constellation Cassiopeia. So a lot of my coworkers actually work on star-forming regions like these, and I thought it would be interesting to invite one of them to talk about this specific star-forming region. So here is Adam Avison with NGC 281.
The NGC 281 Nebula is also known as the Pacman Nebula. I think the name Pacman Nebula alone is sufficient to give you a good idea of what the object looks like. It has an angular size on the sky of around 30 arc minutes, or half a degree, which is approximately the same as our moon. And if we scaled up the real Pacman to the size of the NGC 281 Nebula, then each pixel would be 2.31 arc minutes across. The Pacman Nebula is an emission nebula which is created by the hot, young, massive stars forming within it. These stars are very hot, meaning they emit enough ultraviolet light to ionize the gas surrounding them. The young cluster in the larger NGC 281 complex is known as IC 1590. We know that these stars must be young, as the more massive a star is, the shorter its lifetime, so to see a region of ionization means there must have been a recent period of star formation in the vicinity. It is the ongoing star formation in the NGC 281 region which makes this object particularly interesting to astronomers. As the star formation in the region is fairly dispersed, compared to the concentrated star formation more typically seen in giant molecular clouds, NGC 281 is a great testbed for studying different modes of star formation. In particular, NGC 281 provides potential examples of triggered star formation. Most typical modes of star formation occur spontaneously within molecular clouds when clumps of gas become sufficiently dense to begin to collapse under gravity. Triggered star formation, on the other hand, occurs in the presence of some additional influence, primarily the impact of previous generations of stars through either their supernova explosions or the outward radiation pressure from existing stars. Both these factors generate an outward force which gathers up material, creating the densities required for star formation to take place. NGC 281 seems to possess two regions of triggered star formation, both supernovae triggered from a previous generation of stars and triggered by the interaction of a molecular cloud with the edges of the Pacman Nebula itself. As such, comparisons between the two different modes of triggered star formation within the region cannot be made. However, star formation is generally a messy process, so study of this topic is still ongoing. NGC 281 also contains several examples of my favourite type of astronomical object, the maser. MASER is an acronym which stands for Microwave Amplification by Stimulated Emission of Radiation, so the same as laser but with an M. In the case of those observed in NGC 281, we are talking about water masers, emitting primarily at a frequency of 22 GHz, which is a wavelength of 1.36 centimeters, which is little more to the radio regime than microwaves, but nobody uses the term razer. Masers are interesting objects when observed in astrophysical sources for a couple of reasons. Firstly, to create a maser with a certain molecule requires a specific set of environmental conditions, for example, the correct abundance of that molecule at the right temperature in the presence of a particular amount of radiation at the right frequency. So if you see a maser in a given source, you know that around that source, those environmental requirements have been met. Better yet, you might find two different species of maser around the same source. for example water and methanol. As mazes of methanol and water require different conditions to trigger them, you can use their relative positions in a region to give you clues as to what's happening around your target of interest. The second reason mazes are useful is that they are small but exceptionally bright. Mazes, particularly water mazes, are among the brightest sources seen at radio frequencies. As a comparison, some water mazes are 10 billion times brighter than the sun at radio frequencies. Their brightness and compact nature makes them hard to miss in observations and allows exceptionally accurate positions to be measured by using very long baseline interferometry. Once you have a couple of high accuracy positions for a source measured at different times, you can use techniques of parallax to find a reliable distance to the maser and therefore the astronomical object you are interested in. In the case of NGC 281, this technique has been applied by astronomers to provide a distance to the target of approximately 2.9 kiloparsecs, or around 90 million trillion meters. Given this, the Pacman Nebula is approximately 25 parsecs across, or the distance to Proxima Centauri, our closest star, and back 9.7 times. And getting back to the hypothetical Pacman Nebula pixels, each one would be a little under 2 parsecs across, or 1.5 times the distance to Proxima Centauri. So, in NGC 281, we have an interesting region of ongoing star formation which will help us better understand what happens when older generations of stars trigger star formation for a new generation. Thanks.
And that was Adam Avison with NGC 281. The location on the Earth's surface corresponding to the position of NGC 281 in the sky is an area just outside of Venje, Sweden. Venje is a small residential town located slightly inland from the coast of Sweden, about 20 kilometers south of Halmstad. The oldest building in the Venje area is the church, which dates back to the medieval era. The recreational facilities, including the pool and the dance hall, are also very popular with local residents. The area is surrounded by farmland and a couple of quarries lie just south of the town. The website for this podcast is www.randomastronomicalobject.com. You can go to the website to download episodes of the show, read information about the astronomical objects, view images of those objects, and send me random feedback. And talking about the feedback, I had to add Kapchka to my feedback page because I was getting way too much spam. This is the type of web page plugin where if the website thinks that you're a robot, you are asked to identify all of the pictures that contain things like traffic lights, or buses, or crosswalks, or luminous infrared galaxies. Among other things, I got spam offering me thousands of email addresses so that I could spam other people who don't want spam, an offer to provide me with malware for my website with a free demonstration showing how I could infect my own computer with that malware, and an offer to convert the text on my website to an audio format. I'm hoping that the Kapchka will at least reduce the amount of spam that I get, but I'm still concerned that the spammers are going to get past this thing. My special guest this week was Adam Avison. The audio was recorded and edited by George Bendo and Adam Avison. The music is Immersion by Sasha Endy at www.sasha-endy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The sound effects are from the Freesound Project at www.freesound.org. Thanks for listening.